So in this video we will study about the ionization energy and trend in the periodic table. So what is the ionization energy? Ionization energy is the minimum energy required to remove one electron from the ground state of the gaseous atom or ion. So if any atom is there and if you want to remove one electron from the atom from the gaseous state or any electron from the ion, and so you need to give some energy, and that energy is called ionization energy. It is represented by I, and the first ionization energy is the energy required to remove the first electron, and then there will be second ionization energy is the energy required to remove the second electron. Likewise, there will be third ionization energy, fourth ionization energy, fifth ionization energy. So we represent like I1, I2, I3, I4, like that. So ionization energy, first ionization energy, second, third, fourth, fifth, and so on. So the higher the ionization energy, the more difficult to remove an electron. So here is an example. If sodium is in the gaseous atom, is in the gaseous form, and if we want to remove one electron from the sodium atom, and the energy is required, that is called ionization energy, and we are removing the first electron from here, so this will be first ionization energy. And it require more energy to remove each successive electron, because when all the electrons, valence electron, have been removed, it takes a great deal of more energy to remove the next electron from the core. And this table shows that you can see this table shows the successive value of ionization energy I from the element sodium through the argon in kilojoule per mole. So this is first ionization energy, second, third, fourth, fifth, sixth, and seventh, like that. And if you will see the values, first ionization energy for the sodium is 496 and second is 4562. So always the second, third, or successive ionization energy will be higher. So as you will remove more and more electron, you require more and more energy to provide to remove the successive electrons. So this is first ionization energy for each element. This is the second, this is the third. Here there is no such electron cannot remove, that is why there is inner shell electron. These are the inner shell electrons will be removed again. And then we have to talk about the periodic trend for the ionization energy. So I1, which is our first ionization energy, generally increases across a period. Means if we are going from left to right, ionization energy will increase, and I1 generally decreases from down a group. So down the group is decreases. And S and P block element shows a larger range of value of S1 I1, but the D block generally increases slowly across the period. F block element shows only small variation. So you need to just memorize this trend like this one. Within each group, first ionization energy generally decreases, and with increasing atomic number, but within each period the first ionization energy increases. So this is increasing order and this is decreasing order here. So probably this arrow must be go like this from bottom to top. So let's talk about a little bit more about the ionization energy. So irregularities in the general trend. So the trend is not followed when the added valence electron in the next element enter a new sublabel or higher energy sublabel. It is the first electron to pair in an orbital of a subcell electron repulsion lower energy. What does it mean? It means if removal of the electron, you can see from oxygen, is easy compared to the nitrogen, because nitrogen have half filled orbitals, and half filled orbitals are more stable than unfilled or incomplete shell the orbitals. So oxygen, removal of the electron from the oxygen is easy compared to nitrogen. And this is one more slide to understand in a little different way, that periodic trend in of the ionization energy. Inner energy required to remove an electron from an atom decreases for those electrons further away from the nucleus. So hydrogen has 1 electron only, lithium has 2, so sodium has 11, lithium has 3, sodium has 11, and potassium has 19. But here they are showing only valence electron, last shell electron. So last shell electron in the hydrogen is very close to the nucleus, and as you will move from up, they are far away from the nucleus. So removal of the potassium electron is very easy compared to the sodium, compared to the lithium, and compared to the hydrogen. So ionization energy will so you can see here the increasing distance from the nucleus, and ionization energy higher will be here and lower will be here. So as they will far away, the electron will be far away from the nucleus, it will be easy to remove the electron, and ionization energy will be lower. Next is we can also understand through effective nuclear charge. So energy required to remove an electron from an atom increases as the number of proton in the nucleus increases from a given value of n. So what does it mean? Lithium, beryllium, carbon, nitrogen, and fluorine all are in the n is equal to 2, means quantum number 2 electron cell, and the nuclear charges increases with atomic number, and the electrons are more tightly held. So from here to here, electrons are more tightly held, so the ionization energy will be greater to remove those electrons. And this slide also shows some trend, how removal of electron from the helium is more difficult compared to lithium, and then compared to neon. So this is trend from first ionization energy, and all these helium, neon, argon, krypton, xenon, radon, they are stable inert gases. So inert gases have very high effect first ionization energy compared to any other element. So and this picture also shows the trend of first ionization energy. So first ionization energy increases from left to right in the periodic table, and first ionization energy also increases from bottom to top, and also increases from bottom to top. So this was all about the first ionization energy of the element, any atom, to make to remove one electron from them, and how that trend is work in the periodic table. So next we will study about the electron affinity in the next video.